All right, we're doing the Unit 1 test. Okay, so we have this equation. The height is dependent on this equation. And once again, if we're talking about something being tossed up in the air on the earth, there's two possible numbers that would be here in front of the t squared. Negative 16t squared tells us time is in seconds and the height is in feet. If it's negative 4.9 t squared, this is telling us the time is in seconds again and the height is in meters. Acceleration due to gravity is 32 feet per second squared, and that's what it would, half of it goes here in front of the t squared according to what Galileo learned. If we're talking about the English system, if we're talking about the metric system, gravity is 9.8 meters per second squared, and half of that is 4.9, and that's what we put there. So we have the 4.9 one, and so it tells us the time is in seconds and the height is in meters. Okay, so if we determine h of 0.5, then we're going to find it the height in meters, and if we put 0.5 in for the second, so we get negative 4.9, 0.5 squared plus 10 times 0.5 plus 5. And you can type that in your calculator, and you got to do the power first if you're doing it with not a scientific calculator. I'm going to do it on my scientific calculator, and so I got to do negative 4.9 parenthesis 0.5 close parenthesis squared plus 10 times 0.5 plus 5, and I get 8.75775 meters is the height after a half a second. Determine the maximum height. So I can go here and type in the equation, negative 4.9 x squared on the calculator plus 10x plus 5, and if I go zoom 6, I see pretty much the whole graph. It goes off the top there just a little bit. Okay, now that tells me that it got to a height that's about 10, and it started at a height of about 5 and landed after 1, 2, and some seconds. Okay, so what's the maximum height? On the calculator, we go second, calculate the maximum, and I have to tell what it's between, and it's somewhere between 0 and 2 seconds. So I press 0, enter, 2, enter, I think it's about 1 second, and it says it's 1.02 seconds. But the height that I asked for is 10.1. Now if I do it on Desmos, you can type it in with a t, but if you do, then you have to say h of t or something like that. Or you can just go put x's like I did on the calculator. It'll automatically graph y equal to that. And then to find the maximum, if I slide this Slide this down and tap the top. It says at 1.02 seconds, it's at a height of 10.1 meters. If I want to know when it's at a height, when the height is 7, well, that happens on the way up and on the way down. So there's 2 times when it's at a height of 7. On the calculator, we can go to the y equals and just say 7 graph, and then find out where it intersects. Second, calculate the intersection. And is this one of my curves, the blue one? Yes. Press enter. It's on the red curve, and red is 7. Is that one of the curves? Yes. Enter. Move close to it, and that's my guess. And it says the guess should have been 0.225 seconds rounded. It was at 7 meters. And if I go second, calculate the intersection, that the blue curve is one of the curves, the red curve is one of the curves, so I press enter, and then I move close to the other place I want to find, and I press enter, and it says 1.816 seconds. 1.816 seconds. So there's the 2 times. That's the. What is the meaning of what you just found? The 0.225 seconds is when the ball is 7 meters high on the way up. The 1.816 seconds is when the ball is 7 meters high on its way down. What's h of 2 minus h of 5? Well, it's the difference between h of 2 and h of 5, but what does it mean in this situation? It's the difference in the height at 2 seconds and at 1.5 seconds. So it's how far did it fall, since between 1.5 and 2 it's on its way down. It's how many meters the ball fell between 1.5 seconds and 2 seconds. If I was doing those last 2 on here, on Desmos, I'd be typing in over here another equation. I'd write y equals 7, and if I click on the point, I get the 2.225 seconds. It's at 7 meters, and 1.816 seconds. It's at 7 meters. And that's how I would have done D. Okay. That's number 1. Number 2. The graph to the right is the velocity in miles per hour of 2 cars. The red car is the horizontal line. So Where's my red pen? I don't have it here. Oh, there it is. The red is the horizontal. So this is I'll make it red, indicating the red car. And the sloping line, the other one, is the blue car, just to help me see the difference. This is a velocity graph. The vertical axis is in miles per hour, and the horizontal is in minutes, and that's time. So velocity at times 60, so I go to 60 of the blue car, so I got to go up to here, and that looks like it's a little more than 40. There's 50, there's 60, so it looks like it's about 42 or 43. And this is in miles per hour. What's the acceleration of the red car? Well, that's the slope of the line, and this slope is 0. So it's 0, and the acceleration is in change in the miles per hour. 0 miles per hour per minute would have been the units on that if you put units. I accepted no units, but I did not accept incorrect units for full credit. What's the distance that the red car goes in 20 minutes? Well, if it's traveling at 40 miles per hour and it goes for an hour, it goes 40 miles in 1 hour, but I want to know how many miles it goes in 20 minutes, which is one third of an hour. So it's only going to go a third of this distance, so I'm going to do 40 divided by 3, which is 140, not times, divide. 40 divided by 3. 13 1/3. If you want, the distance is equal to the velocity, 40 miles per hour, times the time. And the time of 20 minutes is 1/3 of an hour, times 40 miles per hour is 13 1/3 miles per hour. And what's the intersection? Be careful when I do the retest that you read carefully what I put, because I might change some of these. But anyway, this is the velocity of the blue car. This is the velocity of the red car. So at 50 minutes, both cars are traveling at 40 miles per hour. Remember, this is velocity, not their distance. If this was distance graph, that's when the distances would be the same. They're both at the same place. And they start at different distances, but here they started at the same distance, we think. We don't know that, but we do know that their both velocities at 50 minutes were 40. That's page 1. Page 2. And I'm going to pull this camera down closer so you can see what I'm going to look at here. Because some of you had some trouble with this. It's not real well in focus. It's too close. Please focus. Is there a way to make this focus? Not manually. Well, maybe. Let me put this on. And maybe I can zoom in with my mouse here on this camera. Okay. I don't like what it's doing. Okay. All right. Let's just look at this. I'll try to be as clear as I can with what we had on our test. So there's the end of the line, and it looks like it lines right up with that mark. And I look at the end of this line, it looks like it lines right up with that mark. And when you count on a ruler, you count how many steps it is, not how many marks. So it goes this 1/16 of an inch, another 1/16. There's 16 of these gaps between 0 and 1. 1, 2, 3, 4, 5 gaps. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 16 gaps. So I want to count gaps here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I messed up here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 to here. 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. 26 gaps of 1/16 inch, which is the same as 13 gaps of 1/8 inch, or 16 of them would be 1, and that would leave 10/16, or 8 of them would be 1 and leave 5/8. Any one of those 4 answers is correct, but as you count the spaces, not the marks. Okay. All right. Now we have this 8.5 by 14 full paper being folded. And if you fold it up on the side, 1 3/8 on one side, it's going to have to be 1 3/8 on the other side. So the length, see that's 14 inches, is going to be reduced by 1 3/8 inches on both sides. So we got to do double that. So it's 14 minus 2 inches, and 3/8 twice is 6/8, which is 14 minus 2 and 6/8 reduces 3/4 of an inch. So 14 minus 2 is 12, and then minus 3/4 more leaves 11 1/4. If you want to do it on the calculator, 14 minus 2 parenthesis 1 and plus 1 and 3/8 more. 3 divided by 8. So you do 1 plus 3/8. 2 of those taken away from 14. And you get 11 1/4 inches. 11.25. And that's inches. Double mark as inches. The width would be 8 minus 2 times 1 3/8, or 8 minus 2 3/4 minus, which is 8 minus 2 is 6, and minus 3/4, 8.5. Dang it, 8.5. 1/2. 8.5. 8.5 minus 2 is 6.5. Minus 3/4. 3/4, 2/4 is a half, so I'd get rid of the half. Be, I'll write this out. 8 1/2 minus 2 minus 3/4, but 3/4 is 1/2 and another quarter. So there's 3/4 and the 2 that were taken off. This minus a half takes that off. 2 from 8 is 6. Minus a quarter is 5 3/4. Now again, if you can do this on the calculator. So bring up what we had and make it 8.5 minus 2 of the 1 3/8, and we get 5 3/4. The height is not double. The height is going to be that 1 3/8 on that side, and on that side, that side, and that side. It's going to be height is going to be 1 3/8 inches. If you do it in decimal, 1 plus 3 divided by 8 is 1.375. The volume is going to be these three. Oh, this is 5.75 inches in decimal. Would be these three multiplied. 11.25 times 5.75 times 1.375, and that's going to be inches times inches times inches, so it's going to be cubic inches. Inches times inches, inches to the third. So I got 1.375 times 5.75 times 11.25, and I got 88.94 inches cubed. Inches times inches times inches, inches to the third. Or you can say cubic inches. Either way. So now what's the formula? The volume as a function of x, so x is how much we're folding, is going to be 14 minus 2x's times 8.5, I'll do it in decimal, minus 2x's, times the height, which was just the x. Length times width times height. Instead of 1.38, we do an x, an x, and an x. And then if we use technology to find the maximum, we would type exactly that, 14 minus 2x, close parenthesis, open parenthesis, 8.5 minus 2x, close parenthesis, times x. And I can put the x in parentheses or not, and get rid of the 7, and graph, and it goes way higher than I can see. If I go to the window and say I want to look higher, like maybe 200, and graph, I can see it. It goes from 0, goes up, then it comes down at 4.25 and back up at 7. Okay. What's the x that gives the maximum? So second, calculate the maximum, and that maximum is somewhere between 0 and 4. 0, enter, 4, enter, and my guess is 2, and it says 1.713. 1.713 inches, since this is in inches, for the height that we fold up. Determine the maximum volume, and that's 91.9. And that would be inches cubed. And this should be more than your answer here. Unless the size I give you is exactly the right amount to get the height, and it wasn't. It's I said folded at 1 and 1.375 or 1 3/8, and this is more than 1 at 0.375, and it gives us a greater volume. Now, these x-intercepts, 0, 4.25, and 7, you can find them by second. Calculate the zeros, and you have to put bounds. So you can look for the one between -1 and 1. -1, enter, 1, enter, and guess 0, and it says, yes, 0, it's 0. That makes sense. If x is 0, the amount we're folding up is 0, the box has 0 volume. Folding up 0 creates no box. If you fold it up at 4.25, that's half of it, which is 1/2 of the 8.5. It's like this piece of paper being folded 4.5 and 4.5, going to give you no bottom because it's going to be 0. Half of 8.5 inches, which gives a bottom 0 wide. That's why it says there's no volume on there. The volume is 0. And then at 7, which is 1/2 of 14 inches, which gives a bottom of 0 long. So if this was 14 and we fold it up this way, 7 and 7, it would have nothing as the bottom, because it would be half. Now, just to get those on some of those numbers off of Desmos, I'll turn off what we just did for the earlier problem there and turn on Desmos. And here's the graph, and we have to see up higher. So if I zoom in, the top is right there. 1.714 and 91.9. And you can type it in with X's. If you do it with something else, then you have to put H of whatever variable that is, or Y equals or something. Okay, so you don't want to fold it more than 4.25 because that makes 0 bottom, and you can't do more than 4.25. You can for this direction, but you can't for this direction. So what you fold up has to be somewhere between 0 and 4.25, or 4 1/4. That's the only domain for this that makes sense. Some side that's somewhere less than half this way and more than 0. If you don't fold anything up, you don't get a box. You wouldn't want to fold up negative amounts. So for this situation, this is the domain. And what's the range? The range is, again, the y values. What do you get out if you do something between 0 and 4.25? Well, if you don't do 0 and you don't do 4.25, you won't get 0. So you're not going to get 0, but you will get up all the way to your maximum, which was 91.9. Now that's a rounded off number, so you can put a bracket or a parenthesis. I don't care, because we know it's a little bit more than this, so probably a parenthesis is more appropriate. It can go, or maybe a bracket. I don't know. You can debate that. I'm not going to be picky on that one, but having a number close to the maximum is important. 0 you can't include because you're not going to do it here and you're not going to do it there. Okay? This page. If you start pouring water into something that's wide, it's going to start, the water will start rising. And as it goes up, if it gets narrower, it's going to go up. It's not going to take as much water, and if you're pouring it in at the same rate, the height is going to go faster. So it's going to start off going slow, and then it's going to start going faster. So the height will start going up slow, and then it'll go up faster. As time goes by, the height will do that. Now in this one, it's starting small and getting wider. So it's going to start going up quickly. It's going to go up quickly and then slow down, but it's still going to take some time. And about here, it's going to change direction and go from this slower to faster at the end. And it should be similar in slope here to the end, because this is the steepness is how fast it's going. How fast it's going here slows down, and then it speeds back up to the speed it was at the beginning. On this one, I was not as picky as I'm going to be on the retake. So it goes slower here, and then it picks up speed. Slower and gradually picks up speed. And then for this part, it's going to go the same speed all the way through, so I should have a straight section. And then it'll start slowing down. And it looks like that's a little wider than this, so it'll slow down so it's not as steep as the beginning of this. Okay. Now on these, let's see if we can understand function notation a little bit better. So, 30 miles per gallon. If I multiply it by the number of 30, number of gallons, the gallons, this will have units of gallons, and the gallons will cancel, and I will get the number of miles. So the distance, miles, will be 30 miles per gallon times the number of gallons. This will cancel out the miles, the gallons in the miles per gallons, and give me how many miles. Or another way to say it, 1 gallon will get me 30 miles. 2 gallons would get me 60, so we can see that the number of gallons times the miles per gallon will give us a distance. So we give this equation gallons, and it returns the distance miles. You input gallons, out of it comes miles. a distance. This one, you have to input the time and get the distance. Well, just like this was miles over gallons, this is miles over hours. So that if I multiply by hours, the hours cancel and I get the miles. So it's going to be 50t, where the input is the time in hours times the miles. So 1 hour gives you 50 miles, 2 hours, 100 miles, 3 hours, so on. And we get the distance, the miles. So now we want to do the reverse. So we're doing the inverse of this. So if you wanted, you could say the distance was 30 gallons, 30 times G. And if you wanted to reverse this, we can divide both sides by 30 and get that the gallons is the distance divided by 30. So this one, you give it the distance, you divide it by 30 miles per gallon, and you'll get the number of gallons used. So if the distance is 60, and you do 30 miles on 1 gallon, 60 divided by 30, you'd say it would take 2 gallons. Okay, and same with this one. Since this was 50t, doing the same logic there, we're going to get the distance, what we had out, is going to be divided by 50 is the t. The d was 50 t, so if I solve for the t by dividing by 50, t is d divided by 50. Okay, so now we have to create one that we can give it gallons and it gives us the time. Well, there's only one that gives us time, and there's only one that we give it gallons, so we got to put these together. And we have to give it gallons, so we have to start with this one. So it's going to be 30G, and 30G gives us a D. And that's what this one takes. So in place of the D, which is this, we put this in place of the D and then divide by 50, and it produces a T. So that's the kind of logic you have to go through to get the right equation. You have to start with one that has a G and in one that has T coming out. G goes to D, D goes to T. So you put this one in that gives this one that gives us D in for the D, and we get T. Okay. And finally, the last page. Okay, we have F this way, K's on the graph, and G and H are in the table. It says, look at 3 on the X on the K graph, and the Y is 1. So K of 3 is 1, and so we have to do G of 1. So we go make X be 1, and what's G come out to be? And that comes out to be 0. This says subtract. So you got to put minus 2 into K. K's the first one here. K minus 2 is 6. Minus 2 on K is 6. K of minus 2 minus G of minus 2 is what this says. So this is 6 minus and G of minus 2. So G is here, and minus 2, it's 0. So 6 minus 0 is 6. Now we're supposed to know when f of x, what x does f of x give us 3? So f of x is 2x minus 3, and we're supposed to get 3. So we have to figure out the x that will make this turn into 3. And we can do that by going plus 3 on both sides, and we get 2x equals 6. Divide by 2 on both sides, and we get x equals 3. If we use 3 for the x, 2 times 3 is 6, minus 3 is 3. We get 3 out. If you want to do it a different way, you could go to Desmos or a calculator, and I'll clear that and that and that and write 2x, what was it, minus 3? Minus 3. Minus, just do minuses, minus 3. And I want to know what gives me 3. So then I would go down here and go y equals 3. And I'll need to zoom in. And there's the 3. And here's the line. And it looks like 3 gives me 3. Okay, k of 0, we start with that one. Start from the right and work in. So 0 gives me 4 on this graph. So I have to do f of 4. And f of 4 is 2 times 4 minus 3. So that's 8 minus 3, or 5. So then I have to do k of 5. Because it says k of whatever this worked out to be, and that's all 5. So I go to the graph and go to 5, and k is minus 1. F inverse. So this is where you take the equation, which was y equals 2x minus 3. Do the y and x swap, and you get x equals 2y minus 3. X becomes y, and y becomes x. And you solve for y by adding 3 to both sides, and you get x plus 3 equals 2y. Divide by 2, and y for the inverse, the y for the inverse is x plus 3 divided by 2. Quantity divided by 2. G inverse. Now you can only do inverses if it's a function backwards. And G if we have these inputs for G, we get these outputs. To go backwards, you have to have on this no duplicate outputs. So 0 and 0 don't work. 0 would have to go to minus 2 and to 1. So it's not a function. So we can't write the function. Now for H, these went to these, and there's no repeats, so we can do the inverse, and so we do the table reverse. The x becomes what was the y's, the outputs, the h. So it's 1, 2, 3, minus 2, minus 1. And the inputs, that becomes the inputs, and the outputs are the old inputs. Minus 2, minus 1, 0, 1, 2. And that's the H prime inverse, H inverse prime. Excuse me, H inverse of X. Too much calculus, they talk about primes. All right, so if we put 3 into H inverse, we get 0. Or if you want here, we put in 3, we get 0. So this part's 0, and we have to do f of 0. So 2 times 0 is 0 minus 3 is negative 3. Okay. Okay. And finally, the last problem. So you need to be good at reading your coordinates and graphing. Let's just start right here. This is 0, 7. Over 0, up 7. So the inverse, I want to reverse those, so I have to graph 7, 0. 7, 0. So this point is moved to there for the inverse. This point is 2 in the x, 3 in the y, approximately. So the inverse would be 3 in the x, 2 in the y. This point gets moved to there. And between these 2 points is a straight line, so between these two will be a straight line. Between that point and that point's a straight line, and this point is 3, negative 3. So its inverse is negative 3, 3. And that's a straight line from here to here, so it's from here to there. And then we have to do this crook that goes to 6, negative 5. So I got to go to negative 5, 6. Negative 5, 6, there. And it's almost a 90-degree leaving this, so to leave this at 90 degrees, it's either that way or this way, and we have to go to this one, so it must be crooked like that. You can check in between to make sure you're doing it the right way. This is 5, negative 3.5. So over here we should do negative 3.5, 5. And this place was negative 5, 6. That'll help you get the bend in the right direction. And the only point that doesn't change is 2 1/4, 2 1/4. And once again, if you're switching the x and y to find the inverse, the only place that doesn't move is where the x and y are equal. 0, 0, if it was on it, wouldn't move, or 1, 1, or 2, 2, or 2 1/4, 2 1/4, or 3, 3, the y equal x line, where the x and the y coordinates are the same. This is the line of reflection. You can actually put a mirror here and look at this and draw what it would look like here. Put a mirror and look at this side, and this will look like this, and you draw that. It's a mirror over the y equal x line. Now you didn't have to draw that line, but this shape should look just like that shape. Can you see how shoot, shoot, shoot looks like that mirrored over? Okay, that's the test.